Problem 4. Assuming gasoline of specific gravity 0.69 flows in a 450 mm diameter steel pipe, 1,200 meters long at the rate of 9 meters per second. The valve is located at the end of this pipe. Assuming the pipe is considered rigid and bulk modulus of gasoline is 1.3 gigapascals, so calculate the time for the pressure wave to travel round trip. The maximum pressure due to fluid hammer at the midpoint of the pipe if closed in 2 seconds. The maximum pressure due to fluid hammer at the midpoint of the pipe if closed in 1.5 seconds. So first, let's compute the celerity because time for the pressure wave to travel round trip is 2L over C. So C is square root of E sub B over density only because the pipe is considered rigid. So square root of 1.3 times 10 to the 9 over 690 kilogram per cubic meter, the density of gasoline. So celerity is equal to 1,373 meters per second. Then substitute, capital T is 2L over C, 2 times length, 1,200 meters long, here over 1,373. So that time for the pressure wave to travel round trip is 1.748 seconds. The maximum pressure due to fluid hammer at the midpoint of the pipe is closed in 2 seconds. Since the time of closure is 2 seconds, which is greater than 1.748, it is a slow closure. Then the pressure at the valve is denoted by pH prime, which can be computed by proportion. So first, let's solve for pH for sudden closure, which is equal to C density V over 1000 to convert it to kilopascals. So 1373 density of gasoline 690, V is 9 meters per second over 1000. So pH is water hammer pressure for sudden closure is 8526 kilopascals. Then since we're looking for the pressure at the midpoint on the pipe, it is just pH prime as to 1.748. The smaller time equals 85226 as to 2. So pH prime is 7452 kilopascals. So the pressure at the midpoint of the pipe is half of this value, 7452, because this is the figure. So PM is 1/2 of 7452. Remember, this is the midpoint of the pipe. This is the normal hydraulic grade line. Then when the pipe is closed slowly, then the increase in pressure at the valve is 7452. Then it decreases uniformly back to normal at the reservoir surface. So P sub M at the midpoint is 3726 kilopascals. For 4.3, the time of closure T sub C is 1.5. This time it is less than 1.748. So this is slow. This is sudden closure. So 2XO over 1373 because the maximum water hammer pressure or pH will extend for certain distance at XO from the reservoir. So round trip distance 2XO over celerity is equated to the actual time of closure. So XO is equal to 1030 meters, and it is beyond half of 1200. So it is somewhere here. Then by similar triangles, PM as to 600 equals 8526 as to XO. So P sub M as to 600 equals 8526 as to 1030. So the pressure at the midpoint on the pipe is the increase in pressure, the fluid hammer pressure is 4967 kilopascals.